So now we're going to move on. We're going to keep talking about triangle congruence, but new ways for us to prove them. Side angle side and hypotenuse leg. Okay, so let's start with side angle side. Now, typically what I have people do is we partner up. I give everybody a ruler and a protractor, and I basically say, here's what you're going to do. You're going to decide as a group on an angle, say 50 degrees. And you're going to decide on some side lengths. Let's say, 3 inches, 4 inches. And then I'd say, can you use your ruler and protractor to actually draw that angle? So can you actually draw like 3 inches, 4 inches, with a nice little 50-degree angle. And it would be your partner's job to do the same thing, right? An exact copy of what you're doing. 4 inches, 3 inches with a 50-degree angle. And then what you would both do is use your ruler, and can you connect the two? And then I'd say, well, now can you compare your triangles to each other? And what you would find is, you know what, Mr. Card? They're the same. Yeah. And so what this side angle side postulate does is basically guarantees, when the angle is fixed into place between them, that's a huge part of that, is that it's side angle side where the angle lies fixed in between the two. And when that is your situation, it locks into place that third side. So side angle side kind of moves towards side, 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 in that it proves that if this angle is in between them, it guarantees that a third side will have to be the same, and therefore they're congruent, because we talked about that in the last video. Side, side, side. It's a postulate. I can't really prove it. This is part of the proof, is then using side, side, side to prove that this works. Okay? And that's how we get to side angle side working. All right, so moving on, we got to talk about this idea of hypotenuse leg, okay, which is kind of an interesting situation. And I'll just go over what I have here, okay, guys? This is something we did in class, and I'll just sort of summarize what's happening here. You can pause the video, take a look at it, okay? We're using the Pythagorean theorem as our proof here, because normally when you have angle side side, it doesn't work. And that's what's going to happen here with hypotenuse leg, right? I have an angle here, 90 degrees, fixed into place, and then I have these two sides, right? But the angle is not fixed in between them, and normally that's bad, right? Normally the idea there is what's called the hinge theorem, meaning that, you might be able to have two sides that are the same, but if I change this angle here, right, if instead of going this way, I think the best way actually for me to do it probably would be to just draw it all as one triangle, where the idea is you could have it obtuse or acute, where I could almost like swing this side to go like this, where and I did a bad job of drawing it, but imagine that this side and this side are the same. See how I almost swung it in like on a hinge? And so, this triangle is totally different from the other one, but it still has the same side. It has this same side, and it would have the same angle right here. And yet they're two different triangles. So normally, angle side side, it doesn't work. It's useless to me. The only time it works is hypotenuse leg, and it's because of the Pythagorean theorem. And it's kind of related to the idea of it locks in the third side and makes it true through side, side, side. So I use the Pythagorean theorem here. A squared plus b squared equals c squared, where the legs squared, the combination of those, is equal to the hypotenuse squared. And so what we can see here is that if I decide to say that this side is x and this is y, and that a and c occur on both, then I can set up a squared plus x squared equals c squared, and a squared plus y squared equals c squared. And what we find is that can cancel. And if I set them both equal to c squared, or if they're both equal to c squared, I can set them equal to each other. The a's cancel, and I'm left with x squared equals y squared, and take the square root of both sides and get that x and y are the same. So because it's a right angle and because it's a right triangle, it has to be that these are the same. Otherwise, the Pythagorean theorem would not work. And so again, it kind of brings us back to the idea of side, side, side. That if I can lock into place the third side, it's guaranteed that the triangles themselves will be congruent. So where does that leave us now? Well, we have side, 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 angle, side, and hypotenuse leg. All three of them sort of related to each other. All right. So you can see here, I implore you, don't use angle side, side when you see this. You got to say hypotenuse leg, because if you say angle side, side, it doesn't apply. Hypotenuse leg, sure. Angle side, side, no way. Okay. And so that's where I'll end this video. There's some good practice problems here at the end. And we'll follow up. We only have a little bit more to go, only 2 more to cover, and then we'll be done with triangle congruence.